Hello. Yesterday we spoke in class about evaluating the limit of a function graphically, taking a look at a graph and determining whether it was a one-sided limit or a limit from both sides, whether that expected y value or limit of the function existed as you got closer and closer to a particular x value. Today, we want to look at doing this numerically. And although this is really more akin to what you would see most commonly in a real-world application, people take sets of data and then they analyze the behavior of that data by making educated guesses. We're not really going to focus too much on numerically here in class. It doesn't show up too much on the AP exam, but you do need to know how to make that guess and how to set it up and interpret it. So we use a table of values to estimate what an expected y value would be as you get closer and closer to some particular x value. All right, so here's kind of an example. If you see in the middle, we are approaching an x value of 1. And take a look at what the x values are on the left side as we head towards 1. We're going from 0.75 to 0.9 to 0.99 to 0.999. We're clearly getting closer to an x value of 1. And from the right side of 1, we're starting at 1.25, then 1.1, 1.01, 1.001. We're getting closer to 1 as we go, and you can see the corresponding y values there. So your job really is to take a look at these corresponding y values and see if you can detect a pattern. Does it look like the y values are approaching a particular y value as x is getting closer to 1 from both the left side and from the right side? So if I take a closer look at this particular one, right, the same table, as x approaches 1 from the left, let me highlight this as we're doing this here, right? It looks like your output values, your f of x values, are approaching 3. They're getting closer to 3. So we would technically say, this is our educated guess, that the one-sided limit, or the limit of f of x as x approaches 1 from the left, equals 3. It's a guess, but we're going to say it's equal to 3. We're making an educated guess. Then as x is approaching 1 from the right, as we already outlined, the y values appear to also be approaching 3. So we would say the one-sided limit from the right also is equal to 3. Now, we have to write this out. You have to follow those 3 rules for a limit to exist to write a valid answer for something like this. But at its base, at its core, this is essentially estimation. We are making our best guess based upon what we see from the evidence in the table. So follow the 3 rules, as I said. Underneath the left side of your table, you would write that. The limit of f of x as x approaches 1 from the left is 3. Under the right side of the table, you would write the corresponding one-sided limit there. And since the 2 of them are equal, we make a conclusion statement using condition 3. We say, therefore, the limit of f of x as x approaches 1 from both sides is equal to 3. Again, it's a guess. It's an educated guess, but it's a really good guess based on the evidence in the table. So if you were to take a look at a quick example here on your own, it looks like, if you're looking at the center of the table, the x value here, looks like we're approaching an x value of 0. From the left, we'd be in negative values on the left of x equals 0. So negative 1/100th, negative 1/1000th, negative 1/10,000th. So we are getting closer to 0 from the left, also from the right, 1/100th, 1/1000th, and positive 1/10,000th. And then look at the corresponding y values that go along with those. The table's already filled out. You just have to analyze it or interpret it. Does it look like, as you get closer to x equals 0, the f of x, or output values, are approaching a particular value? And it does. It does. It looks like they're approaching 2, and that would be the same thing from the right. So to write your answer out, you would write first the 2 one-sided limits under the appropriate side of each table, and then a conclusion. Since they're both equal to each other, you would say that the limit of f of x as x approaches 0 is equal to 2. Now, if you have to set up one of these tables yourself, you have to pick the x values that you're putting into the table. You're going to see on the Delta Math assignment that you guys work on, you'll have to choose the x values yourself. So here's my suggestion. Let's just say, for argument's sake, that we were approaching an x value of 2. Right? If I was approaching 2 from values from the left side of 2, what I would do is I would start 1/10 of a unit to the left of 2. That would be 1.9. Then I would increase by a power of 10, or sorry, I would more appropriately decrease the distance by a power of 10. So then 1/100th of a unit, so that would make 1.99. And then 1/1000th of a unit, 1.999. On the right side of 2, I'd go to the furthest box on the right, and I'd go 1/10 of a unit on the right. Then I would decrease that distance to 1/100th of a unit, and then 1/1000th of a unit. Right? You have to guess what the x values are going to be, but they have to follow the pattern that they are, in fact, getting closer to 2, so that you can look to see if there's a corresponding pattern in the y values. Are the output values getting closer to a particular value? And if they are, then you have an answer here. You have a valid answer. So let's try one of the Delta Math ones. They orient the table vertically instead of horizontally, but I'll use the same setup here, and let's see if we can determine there's a pattern. All right, so here is a Delta Math question, similar to what you're going to be looking at for the homework assignment. Now, if you look down at the answer box, the shaded answer box at the bottom, you can see the two one-sided limits and the final limit from both sides. And then, of course, they ask a question about the actual function value. You can see you're approaching a value of -2. So I'm going to set up my table. I'm going to tap on the x column, and I'm going to choose a value that's 1/10 of a unit to the left of -2. So that would be -2.1, and I try it out. Now I'm going to go 1/100th of a unit to the left of -2, -2.01. And I tap try value, 1/1000th of a unit, -2.001. And I try that value. Now it looks like I'm getting closer and closer to a value of -3. That appears to be the case. So I'm going to make my educated guess here, and I'm going to say -3 over here. All right, now I'm going to go back up to the table, and I'll try it from the right. I need 1/10 of a unit to the right of -2, so that would be -1.9. Try it. Then 1/100th, -1.99, and try that. And -1.999, 1/1000th of a unit. All right, now it does look like I'm approaching a value of -0.4. The values, if I had to make my best guess, do look like they're approaching a value of -0.4, so I would type that in down here, -0.4. Now we can make our conclusion here. The two one-sided limits appear to exist, but they're not equal to each other. So the limit as x approaches -2 from both sides does not exist. And as a final part of the question here, let's just figure out what f of -2 is equal to. I'll type that in. I'll try that out. It's undefined, so I just need to match that in the answer box down here. And then we'll submit, and we'll see what happens here. Okay? And that's the way that you would set up one of these problems, and the way that you write out your answer. You don't have to write it out yourself on Delta Math, but if you had to, you have to write the two one-sided limits, and you have to make a conclusion statement with the limit notation from both sides, whether it exists and what it's equal to or not.